I'm Shannon Swilley Greco at the Princeton Plasma Physics Lab, and this is our Tesla coil.
Scary.
This is my friend Gwen. Don't touch this. This is a Tesla coil, and this probe has super high voltage coming out of it when I turn it on. Low current, so it's not going to electrocute you. So what it is it's generating a high voltage. You can actually see little tiny baby lightning. Part of the sound that you hear is the machine itself. Part of it is little baby thunder. So when we drive enough current through this, we're turning this gas into a plasma. So what is a plasma? It's the fourth state of matter. So when you go from a solid to a liquid, and a liquid to a gas, and a gas to a plasma, each one of those steps is just adding more energy and moving into the next state of matter. Goddess of Thunder, here you go. All right, so what we're gonna do is we're gonna get close to this and we're gonna light it up. Do you feel any little tingle?
A little bit.
You hear that noise? What a good, little baby thunder, right?
It is like a little baby thunder.
So we've got two plasmas going on here. This is much more like actual lightning, but this is a different gas inside here. So this all around us is atmospheric pressure. So it's really, really hard to ionize gas at atmospheric pressure. So it takes a very high voltage to break down the gas into a plasma. And what we mean by that, when we say break down the gas into a plasma, we're adding energy to a gas, the air all around us that is mostly nitrogen and lots of other gases like oxygen and carbon dioxide and water vapor, etc. But we're knocking off the electrons. We're giving it so much energy that it's knocking off the electrons, and it is starting to glow as a result and conducting electricity as a result. So we are ionizing the gas. We are turning it into ions by removing electrons. And this is exactly the same thing as lightning. Lightning in the sky that you see is much bigger than that little ½ inch, right? So imagine how many volts it takes to make lightning go from cloud to ground, or cloud to cloud even. It's a lot. Can you smell that smell?
Yeah.
That is ozone. It's the same smell that you smell when lightning strikes.
Wow.
So we've got one atmospheric plasma, but this plasma inside here is a different gas and at a different density. So it's actually an easier plasma to create because it's so low density. There's a specific sweet spot that's relative to distance between electrodes and pressure and voltage. The density of the gas inside, which happens to be mercury, and it's a different gas at a different density. It's at the density that is optimized for this distance, for this size light bulb, at a normal voltage that might come out of your wall. We're going to give it more than that. And we created a plasma inside. So this is a mercury plasma, and this is a mostly nitrogen plasma. And now hold it up here. And it's not going to the end so much. Just like the plasma ball, it goes through your hand as a path to ground.